So in this video, we're going to talk about the difference between clinical significance and statistical significance. So far we've been discussing statistical significance. In the last few videos, we've talked about power, which is the ability to reject the null hypothesis when it isn't true, or in other words, the ability of our test to detect a statistically significant effect. And we saw that power depends on beta, alpha, the effect size, and the sample size. So let's use an example. Let's say that we have a drug that we think will affect body weight, and we're going to test it against a placebo to see if it reduces weight more than a placebo. So here are the distributions for the drug, which we're going to call the alternate distribution, and the placebo, which we're calling the null distribution. And in this study, we have 200 people. So we have 100 people that are given the drug and 100 people that are given the placebo. And we're looking for a change in percent change in weight between before they took the drug or placebo and after they took the drug or placebo. So you can see here, this is the null hypothesis distribution, meaning there is no change. So the placebo would be that distribution. So that's why the mean of the distribution is at 0. So there's no change because there was no essentially drug given. And then this is the alternate distribution, which is the drug. Now in this case, you can see that the mean of the alternate distribution is -1, meaning that there was a change in weight of 1% weight loss among the people who took the drug. Now the question is that difference statistically significant? And so how do we tell? Well, again, we have a cutoff point on the null distribution, which in this case would be probably around here, right? And then alpha is on that side. And so what we see is that most of the alternate distribution is overlapping with the null distribution. So therefore, it's very unlikely that we're going to reject the null hypothesis and say that they're statistically significant. So the likely outcome here is going to be the acceptance of the null and rejection of the alternate distribution, meaning there is no difference between the drug and the placebo. So now remember what happens when you increase the sample size of a distribution. You narrow the distribution because what you do is you decrease the standard error. So here we have a massive increase in the sample size. So we multiplied the sample size by 100. So now we have 10,000 people taking the drug and 10,000 taking the placebo. And so therefore the difference between the drug and the placebo is the same, right? The effect size is still 1% change. But in this case, the distributions are so narrow that we are very, very likely in this case to reject the null hypothesis, right? Because the very little of the alternate distribution is overlapping with the null distribution. So the point is that the sample size can have a big impact on whether a result is statistically significant. So in both cases, we had a change in weight of 1%. So here this shows this effect size right here, this difference, is the same in each study, right? But in one case it's statistically significant down here because the sample size is so big, the standard error is so small, and therefore the distributions are so narrow and do not overlap. And in the other case, the sample size was smaller, and so the reverse is true. These distributions are much wider because the standard error is bigger, and therefore they overlap more. So what is clinical significance? Clinical significance is whether that difference that you detect, so in this case, it is statistically significant. So you say, oh yay, my study worked, my drug worked, it's effective. So do you want to sell this drug? Say the drug has some side effects, it's expensive, or even it's not that expensive, it reduces weight by 1%. Well, there may not be any clinically meaningful impact of that small change in weight. And therefore, even though this drug is statistically significantly different from a placebo, it's not clinically significantly different from a placebo. So the effect is statistically significant, but not clinically significant. So, just to review real quickly, statistical significance is just simply that the difference that you got in the difference between the control group and the test group, the experimental group, is the probability of finding that, if the null hypothesis is true, is less than 5%, right? So we've been over that. Clinical significance is not a mathematical it's not related to the hypothesis testing or the p-values, right? It's basically a clinical judgment that says this difference that I found in my study, it may be statistically significant, but is it also clinically meaningful? Does it result in a long-term clinical benefit? For example, does, say, the 1% reduction in weight result in a long-term reduction of risk of cardiovascular disease or mortality? So usually when we power a study, in other words, when we decide how many people are going to be in the study, we base that, as you saw before, power is based on an effect size that you're anticipating. And so usually we want that effect size to be clinically significant. So we would never say, okay, we're going to include 1,000 people to see a difference of 1 pound. We don't care about a difference of 1 pound because it's not clinically significant. So like in the case of weight, usually a 5% change in weight has been shown in other studies to be related to clinical benefit long term. And so therefore, in a weight loss study, you would always want to have a difference of at least 5% in the change in weight. Otherwise, it's not clinically significant, even if it is statistically significant. So hopefully that helps.